Yes, sir. So, good evening, everyone. Today, Dr. Sarappreet Singh is here to talk about the influence of air quality on embryo or IVF outcome. To introduce him, it's a pleasure always to be seated with Dr. Sarappreet Singh. Sir has completed his MD from AIMS, a prestigious, and he has also completed his ASHRAE certification as a senior clinical embryologist and also IFS certified. Currently, he is working as head of clinical embryology and andrology at Artemis Health Institute since 2009. So he is having a vast experience in the field of embryology. I can say he's an expert in all the topics which he delivers on lectures on. So he is also chair clinical embryology in IFS from 2024 to 2028 and also the director of Fertilis Academy, where he provides online and offline training in reproductive medicine and embryology related trainings. His area of interest will be cryobiology, male infertility, and sexual health. And coming to the awards won by him, he has many awards. Champion of ISAR Award at ISAR Conference 2020, and also the award of Best Convener Special Interest Group of Clinical Embryology at Fertivision 2019. Best Special Interest Group of Applied Genetics Award in Fertivision 2020 and 2021. So also a winner of IFS Achiever Award in Fertivision 2022. Appreciation Award at Fertivision in 2023. So sir has awards like this, and this is going to continue also, I believe. So over to you, sir.
Thank you, Dr. Lakshmi, for that for your kind words. And I'll be taking the session on impact of air quality in an IVF lab or on IVF outcome. So if I have to introduce the subject, IVF is a very highly complex multi-step procedure, and there are a cascade of biochemical and molecular intracellular signaling for embryonic development. And this outcome is affected by a variety of clinical factors such as stimulation, oocyte retrieval, embryo transfer, etc., as well as environmental factors such as temperature, oxygen, and CO2 control. There is a significant change in the microenvironment which affects oocyte and embryonic metabolism and homeostasis. And this is the reason why even a minor change in the microenvironment will have profound effect on the embryonic outcome and implantation rates. So as you know that the embryo doesn't have a liver or kidney, lungs, nothing to detoxify, and doesn't have a nose either. So you have to feed the embryo with the right kind of nutrients, whether it be air or macro or micromolecules. And the environmental and air pathogens play a significant role on embryogenesis and implantation. So the gametes also require protection from toxic substances such as volatile organic compounds and chemically active compounds. If you look at the sources of air contamination, they can be either external or internal. If you look at the external ones, it can be due to, surrounding areas. It can be pollution from nearby buildings, nearby petrol pumps, malls, busy traffic roads, or industry operating near the IVF center, or there can be exhaust from the car and trucks. So those are the mainly common, external contaminants. And there's a huge list of internal contaminants such as microorganisms. Then the tissue culture dishes which you are using, it is all polystyrene and polyethylene, and they themselves release a lot of volatile organic compounds. Even the refrigerants contain chlorofluorocarbons, so the refrigerator should always be kept outside the IVF lab. Common cleaning and fixation materials, anything which you're bringing in the lab, you have to check for the level of volatile organic compounds. It should not be emitting any volatile organic compounds. So the common hand sanitizers are a source of VOCs. During COVID times, people used to sanitize their hands frequently with hand sanitizers, and that led to the decrease in IVF results. So you should always switch to quaternary ammonium compounds. If you're bringing in new equipment, you have to degas and you have to burn in the new equipment outside the facility or maybe even inside the facility if it's not functional. Once the burning in is done, then you make it operational. Any gasketing, paint, floor, sealing materials, all are a source of adhesives, any kind of pasting material, tiles, sealants. They are all a source of VOCs and can grievously damage the embryonic culture conditions. Also, the lab staff which is coming in, the clinical staff, nurses, your co-embryologists, technical staff, they should be, changing into scrubs which are clean, and they should not be having any practices such as they should not smoke and come, and they should not be wearing perfumes. So everything has to be avoided. Air quality has to be optimal in order to get great results. So if you look at air filtration, there are three different stages of air filtration. First is the core stage or the pre-filter stage, in which pre-filters are usually generally they are broad gauge filters which are inexpensive, and they filter large particles, and they provide initial contamination control. The large particles will get stuck to the pre-filters, and thereby the large particles are filtered first, and they cannot impact the fine filters which are subsequently in the series. The first filter is always the pre-filter. The second filter is usually a fine filter which removes fine particles after the big particles are taken care by the pre-filter. The combination of first and second stage filtration allows filtered air to reach the HEPA filters at an optimal cleanliness grade. So the method used for to assess the saturation of fine dust filters is made by assessing the pressure drop across the filters. The third stage filtration is usually the HEPA filter or high efficiency particulate filters, which are responsible for removing the smaller particles. The HEPA filters are generally essential for clean room classification, and their saturation is assessed by pressure drop. So the HEPA filters generally filter particles which are above 0.3 microns. So now we'll come into the details of how the filters work. Usually, these are the type of filters: pre-filters, which filter particles greater than 10 microns; fine and medium, which take care of particles more than 1 microns; HEPA filters, which are very effective for any particle which is greater than 0.3 microns; ALPA filters, or the ultra filters, which are filtering particles greater than 0.12 microns. So how the HEPA filters work? There are just four mechanisms of particle trapping. One is the diffusion, impaction, interception, and sieving. There is no need of going in the details. Only thing you need to understand is that any particle which is less than 0.1 micron will get stuck due to diffusion. Look at this is the process of diffusion, and the 0.1 less than 0.1 particle will get stuck due to diffusion. Any particle which is more than 0.4 micron will be impacted, will be intercepted and impacted in the substance of the material or of the filter material. The problem is with 0.1 to 0.4 micron particles. These are too large for effective diffusion and too small for initial impaction and efficient interception. So this decreases the filter's efficiency. So the critical range, the 0.3 micron is the global efficiency point, which represents the hardest particles to capture. So if you have to talk about a global efficiency, you have to consider 0.3 microns, because anything less than 0.1 is easily trapped, more than 0.4 is easily trapped, but somewhere in the range of 0.1 to 0.4, especially 0.3 microns, it is the most difficult to trap. And most of the pathogens will be in that range. So in order to, as I told you before, in order to optimize the efficiency of HEPA filters, you need to have a pre-filter, then an activated carbon filter to take care of VOCs, and finally a HEPA filter. The cost of a filter is usually inversely proportional to the HEPA filter saturation. And if you look at the activated carbon filters, which is the second stage filtration, after the pre-filters and the fine filters, you have the activated carbon filters. If you look at the activated carbon filters, they generally will take care of all the CO2, alcohols, aldehydes, all the volatile organic compounds are taken care by the activated carbon filters. And also you require oxidizing media, which is beneficial in conditions having high aldehyde concentrations. Generally, the oxidizing media is alumina. It acts as a carrier for oxidizing media such as potassium permanganate. It's porous and highly absorptive. So alumina is something which will absorb VOCs and toxic gases. These media bind gases which are then chemically broken down by oxidation. For systems that use activated carbon, potassium permanganate reduces the level of oxidation reduction reagents that could also cause problems for culture. So it's a combination filter. Usually it has got activated carbon as well as potassium permanganate. Potassium permanganate is more of an oxidation agent, and carbon is more of a absorptive agent for volatile organic compounds. Another important filtration step is ultraviolet germicidal disinfection. That is, as I told you in the previous slide, the HEPA filter efficiency decreases in a critical range of 0.1 to 0.4 microns. And most of the undesirable microorganisms are in this range, around about 0.1 to 0.5 microns. And to take care of these, we require additional UV germicidal irradiation. And if you talk about the UV germicidal radiation, the most effective is UVC band, which is between 282 to 200 microns. And it is the most effective germicidal effect is achieved by UVC radiation. So these are a part of the filter complex which we generally use. And if you look at the primary mechanism by which UV radiation will kill or be effective on microorganisms, that is the thymine dimerization. So now the question is, which filter system should you choose for your lab? It depends on the air cleanliness class to be achieved, because there are different classes of cleanliness which we'll go on to discuss in the slide, in subsequent slides. Just one second, just one second. Uh, just give me 1 second. I'm joining from the other computer. This computer is giving me some problems. Just 1 second. Sorry, I'll be joining from the other computer, so I'm just stopping the sharing on this computer.
Recording in progress.
So we will be starting the presentation from beginning, because I'd made a new presentation, but because of laptop malfunction, I was playing on the other older computer. So now this computer started working. I hope you can hear me clearly. Lakshmi, can you hear me? Dr. Lakshmi, can you hear me?
Yes, sir.
Okay, so I'm starting the PPT again. I'll be running through the initial slides, because we've done them once.
Okay, sir.
Just give me 1 second, huh? Just we'll be starting again.
Yes, sir.
Yeah, so we will be running through the initial slides very quickly. I'm sorry for the inconvenience. There was some issue in my laptop. It's working again now, so we are resuming the session. So we'll start with a clinical case. Your blast solution rate suddenly drops from 62 to 68%, 38%. Everything is in the lab is unchanged. So what can be the reason? And 6 weeks later, you discover that the hospital has renovated the adjacent ward. There is some construction activity in the adjacent ward, and they have used sealants, they have used adhesives, and that can lead to the disturbance of air quality in your IVF unit. And the question is, could the air be responsible? So as I think we've gone through this slide, that IVF is a very complex procedure, and there are clinical and environmental factors, and any small change in the microenvironment will affect the embryonic development grievously. So with that background, we also have studied that the embryos can't detoxify, so you have to give them very pure and quality air. If you look at the sources of external, then there is a construction, then there are pollution sources such as petrol pumps, construction, etc. If you look at the internal sources, these are even more relevant because this is something which you can control. People come in with perfumes, hand sanitizers, clothing which is dirty, plasticware in the lab, paint, adhesives, equipment such as refrigerants. They do emit VOCs like CFCs, etc. Any new incubators do outgas, any new machines. And HVACs, if they're not properly maintained, HVACs are the heating, ventilation, and air conditioning units. If they're not properly maintained, they can be themselves a source of poor quality air. So, what are the biological mechanism for damage or decreasing the outcome? Poor quality air will lead to VOC exposure, oxidative stress, mitochondrial dysfunction, DNA damage, epigenetic alterations in the embryos. And this will lead to reduced blastocyst development, lower implantation rates, and lower and reduced live birth rates. Now, this is the mechanism which you should have, which should be at your fingertips when you are explaining about air quality. And which air filtration I told you about the pre-filters, fine filters, efficient particulate air filters, and high efficiency particulate air filters also. So we'll not go over it again. Different stages, you know that the first stage is only the pre-filter stage, second stage is the fine filter stage, third filter is the HEPA filter stage, and we have to take care of providing filtered air to HEPA filter because HEPA filter otherwise will get impacted and jammed. So 4 mechanisms of particle trapping: diffusion, inertial, impaction, interception, and sieving, we told you. And global efficiency, you know that it's between 0.1 to 0.4 microns, 0.3 being the mean. So anything less than 0.1 is trapped. 0.4 is again, more than 0.4 is again trapped. Anything between 0.1 to 0.4 is critical and it's difficult to intercept. So the series of filters is pre-filter, activated carbon, and HEPA filter. If you look at the activated carbon filter, the size and type of filters should be designed for IVF labs, air volume providing sufficient turnover rate and exposure time to the carbon filter to remove VOCs from the room air. So oxidizing media, I told you it takes care of the high aldehyde concentration in the environment. And alumina generally acts as a carrier for oxidizing agents. It's porous and highly absorptive, and it binds gases. For systems that use activated carbon, KMNO4 or potassium permanganate reduces the level of oxidation reduction reagents. That could be a problem for cultures. So they are in combination, activated carbon and KMNO4. If you look at the ultraviolet germicidal disinfection, I told you that the UVC band is the most effective for germicidal effect, and generally thiamine dimerization is the major implication of UV radiation, which kills the microorganisms. Now, which air filter to choose? It depends on what kind of air quality you are trying to achieve, the main purpose of controlled environment, the risk that the product or process will involve, type of air to be filtered, that is, it depends on the pollution level in the surroundings. And also the size and type of filters should be designed in proportion to the lab air volume, providing sufficient turnover rate and exposure time to the carbon filter so that it can easily remove the VOCs from the room air. See, the most critical and the silent killers are the VOCs or volatile organic compounds. Particulate, you will take care with the help of HEPA filters. Also, the budget which is to be invested in air filtration has to be considered because there are many kinds of air filtration systems which we will discuss in subsequent slides, and the cost is also a major concern. Many studies have shown that if you improve the air quality, the implantation rates and the embryo development improves. These are some of them. You can take a picture of this. You can take a screenshot. So what are the benchmarks for IVF lab in terms of air quality? The benchmark is there should not be more than 3.5 lakh 0.5 to 5 micron particles. And this condition applies during operation as well as during rest. So the air quality should be grade B in operation and grade C at rest. So anything which is class 10,000 in the ambient environment will be able to support class 100 in the laminar hood. So if your ambient is not clear and good, you will never be able to achieve the right air quality in the laminar hood. So keep your lab clean. Don't trust your laminar hoods in case you're not feeding them with the correct air. So the international norms for microorganisms should be less than 10 colony forming units. VOCs should be less than 500 grams per meter cube. Air changes at least 15 to 20 air changes per hour with at least 20% of outside air, which is required for necessary overpressurization. Temperature 20 to 24 degree depending on the region. Humidity should be maintained between 40 to 45%. And overpressure of at least 30 to 50 pascals, minimum 30 pascals. But honestly, we have tried using 30 pascals. It becomes too much. Anything between 10 to 15 is a more practical solution. This is my own experience in my lab. And we can achieve all this with the help of different air filtration systems. Number one being centralized heating, ventilation and air conditioning system or HVAC units. Most expensive and most efficient. Then we've got the compact filtration systems. And we have got portable filtration systems, like they are similar to what we use in our homes in North India because of high pollution in winters. So we will be discussing about all the filtration systems. The HVAC systems combine adequate supplies of pressurized airflow with temperature and humidity control. So this is the chief feature: pressure control, temperature control, humidity control. There is a series of pre-filters and fine filters in a filtration box. And the VOC filters are installed next to the pre-filters, and then the activated carbon filters and KMNO4 filters which take care of VOCs. And in the last, you have the the HEPA filters. If you look at this, this is the source of air, and you have a pre-filter, you have a heating and cooling unit, and this is followed by a filter box which has got a fine filter, activated carbon and KMNO4 filter. And finally, the filtered air is released through HEPA filters in the lab. And then the air which is filtered is again taken back with the help of return ducts. So this is the concept of HVACs. And for each room, you require different HVACs at different pressure settings. So if you have a higher pressure HVAC in the lab, you should have a lower pressure HVAC in the OT, so that the air flows from lab to OT, and the OT should be a little higher compared to outside. Then the airflow is from lab, OT, and outside. Now talking about the compact filtration systems, they are known as bag in and bag out filtration systems. They are ideal for low budget facilities with a maximum room size of 20 meters square, around 200 to 230 square feet. So if you look at these filter systems, they are more like they are usually they are installed in the adjacent room, and they throw in clean filtered air in the IVF lab. The filter box is a combination of pre-filters, HEPA filters, and even most of the filter boxes will have activated carbon filters also. And they provide high filtration rates and high speed airflow. They provide decent temperature and humidity control, but the pressure differential also they claim to provide, but it is not as effective as the HVAC system. Now, this is a very common example of what we get in our country. This is a lab guard. So if you look at the design of this, the lab guard is throwing in filtered air. This is the room next to the IVF unit. This is the IVF unit, and this is the room next to IVF unit. So the lab guard will throw in filtered air, which will then circulate in the IVF lab, and through a return blower, this will come to the adjacent room again, or a utility room. The important feature which people generally miss is that there is a supply of fresh air which is absolutely essential to detoxify the air. Otherwise, a recirculation will go on pumping in contaminated air. And the split AC is usually installed in the utility room or the adjacent room, because the cold air which is not filtered goes in through the lab guard, and it not only cools the IVF lab or the IVF unit, it also provides it filtered air at a slightly higher pressure compared to normal. A reasonable arrangement to get decent results. If you look at the portable filtration system, they are more or less what we use in our homes. And this is again either a three-stage pre-filter, fine filter, HEPA filter, or it can be four-stage, which is pre-filter, fine filter, carbon filter, and HEPA filter again. There is no positive pressurization, and it just goes on recirculating air, and at some point of time the filters will clog and you have to replace the filters. This is another example of a portable system, Zandair or Coda filter, whatever you may call it. Same kind of arrangement. We are not discussing this again. No temperature or humidity control, no pressurization. And this is an example of a lab in which there is a central placed HEPA filter through which air is entering into the lab. And this is kind of a correct arrangement. If you look at this lab, it has got various HEPA filters, maybe three HEPA filters in the same lab, which will be difficult to achieve the right pressurization in such arrangement. And moreover, the filtered air, the cold filtered air will fall on the instruments if you have got multiple vents in the lab, and it is going to disturb the conditions of the incubators also. So placement of HEPA filters should be central and not multiple locations, because it will create cold spots and hot spots in the lab. And especially the inlet and outlet should be nicely located. Look at this lab. There is inlet is from the top and outlet is at the walls. Whereas in this lab, the inlet is on the top, as well as the return duct is again on the ceiling. So the circulation is not laminar in any way. So when we talk about clean rooms and air quality, it should be pressurized using HEPA filtration, airtight ceilings. Everything should be airtight. There should be a positive pressure which is maintained. No wood, only stainless steel furniture. Constant temperature and humidity should be maintained. And this is an example of a unit which records pressure across two different rooms. And this should always be positive, and the pressure should always be higher in the IVF lab. So if you look at these two doors, the doors are also very important. If you look at this is a hinge door which effectively seals the air. There is no air leak from the sides. Whereas this door, you can see light coming in as well as the air leak will be there. So better idea is to have nice sliding doors which cut off the air in a very, very critical way, and they are absolutely airtight. Then again, and in my practice, I've seen that the communication between IVF lab and IVF OT, this is very important. And any leakage from the communication between lab and OT is a function of square of the radius of all open holes. That is total area of all the holes. So if there is a small opening, then there'll be a huge degree of pressure leak, and the pressure will never be maintained in such labs. Many times we see sliding doors are there, small hatch boxes are there. And look at this lab, which they have got a very normal kind of glass windows. So these are unable to maintain the pressure differential between two rooms. Whereas something like this is a whole pass window, and this is quite effective in cutting the air between any leakage is prevented between two rooms, the lab and the OT. And the best arrangement is this pass-through window, which is not very expensive. It is double gasketed. When you close it, it nicely maintains pressure differential between the two rooms. So simple things bring in good results. Any sliding door effectively seals and there is no pressure leak between the two rooms. So if you look at the airborne pathogens, I told you volatile organic compounds are the silent killers, and they are associated with compromised embryonic development. They harm sperm quality by attaching to the DNA, causing DNA fragmentation and harming the embryos, especially in the later stages of development. And they also react with indoor ozone and release toxic and mutagenic substances. So if you look at the sources of volatile organic compounds, it is construction material, PVC flooring, plastic dishes which you use in the lab, paints, adhesives, cleaning agents, perfume, smoke, sanitizers. And I would like to reiterate here that as low as 2.2 parts per billion is also embryotoxic. And these can be quantified with the help of photoionization detectors as well as identified with the help of gas chromatography. Air quality deteriorates as it passes from exterior of a building to inside of a lab, and again deteriorates inside the incubator. These are all studies which have shown. And most common volatile organic compound is formaldehyde, followed by acetaldehyde. So these are the substances which many studies have shown that they harm human embryos and they are unable to achieve the blastocyst stage. So there is no question of having an implantation. If you, but with time, the lab designs are becoming more and more segmented. In old style, if you look at the old style labs, the general VOC levels were between 1300 to 3200 grams per meter cube, whereas now in the new age ART facilities with segmented lab design and good kind of air filtration systems, this has gone by almost one third. It has gone to almost 340 to 1200 grams per meter cube. So we are improving, and so are the results. As I told you that the outside air is kind of reasonably okay, but as you go in the lab without effective filtration, the VOC levels go on.
What is the matter?
So with as you enter with an ineffective filtration, the VOCs start getting accumulating in the IVF lab, and the maximum VOCs have been found in the incubator also. So you have to take care of your incubators. You have to kind of detoxify them, decontaminate them, and then the results will be maintained at an optimal level. New equipment has to be run in order to dissipate latent VOCs which are produced during manufacturing and during packaging. So VOCs have multiple classes. It's impossible to measure the VOCs. There are of so many different classes. So no one particular instrument can measure VOCs. So it is always better to follow the right practices, follow practices in which the VOCs are reduced to a minimum and they are unable to impact the IVF results. So most common mechanism for VOC remediation is adsorption, oxidative photocatalytic oxidation, and we have covered these two in the previous slides, molecular sieve and oxidation. So we have covered the mechanisms, but we're just revising them. Activated carbon and potassium permanganate filters, they are the most common technique for purification of VOCs because they allow the VOCs to diffuse within its matrix and they trap it there. Alumina is again, it's not only a carrier, but also takes care of the reduction reactions. And any modifications done in alumina by adding chemical materials widen the application. It can then also remove sulfur dioxide and polar organic compounds. So always choose the right dishes. When you bring in dishes, allow them to settle in the outside the lab. There should be a package. There should be a storage room. Let them degas. And when you bring it in the lab, this is a breathable packing. Just open it wide and leave it loose. So the VOCs will be dissipated. Also, you have to use oil liberally in the culture systems because oils not only they not only absorb the VOCs, but they also prevent the VOCs from reacting with the media phase of the culture media, thereby preventing any VOCs from reaching the embryos and harming them. So you should always have liberal amount of oil over the media drops. So this is known as oil sink, in which the oil will absorb the VOCs, and it is a good practice to keep oil in 100 millimeter dishes in the box incubator. So it also absorbs the VOCs and keeps the incubator conditions very neat and clean. Also, one other thing which you can use in your labs, you can use activated carbon, which you can procure from Amazon, or you can procure it from Eureka Forbes, and you can keep it, spread it in the steel plates, and keep it in the lab. It absorbs VOCs for at least 3 to 4 days, and then it needs to be replaced. Any new facility has to be deep cleaned and then utilized. Regular cleaning, even people were using with 70% alcohol, which is not recommended nowadays. You should use either quaternary ammonium compounds. If you can't source it, 6% hydrogen peroxide is also a good idea. Everything has to be alcohol free. And aldehyde based cold sterilizers, sanitizers, cleaning agents with chlorine dioxide are a strict no. Cleaning and cosmetic products, as I told you, should be quaternary ammonium, no perfumes, no third hand smoke. Nobody should be smoking and coming in the lab. Nobody should be drinking and coming in the lab. And operators are the biggest source of VOCs. So minimal traffic in your IVF labs, clean scrubs and post and PP equipment. Computers and accessories. Try not to keep computers and accessories. Even if you have to keep computers in the lab, try using laptops and not desktops. No photocopier, no printer in the lab. So how do you test for air quality? So these are HEPA filter integrity machines, and the test is known as dope test. In this, we throw in aerosol in the outside air, and we check for the aerosol detection after 4 stages of filtration through the HEPA filter. So if you feel that the aerosol is coming and is being detected, that means your filter system has got some leaks and is not effective. Also, you should be counting the particles. As I told you, the particle count for 0.5 to 5 micron particles should always be less than 3.5 lakh particles per meter cube. So take the help of this particle counter, outsource it to a good reliable lab. You can measure the number of air changes and air velocity and uniformity with the help of balometer devices, and even anemometer helps in detecting the flow speed in the ventilation ducts. This is a little technical, but again, something which you can do every day. You can at least, check the pressure differential between IVF lab and IVF OT. You can do it simply with a crude test is using the paper strips and seeing where the paper strips are being blown, whether they are blown in the lab or outside in the OT. So if the pressure is high in the lab, the paper strips will go in the OT. Also, most of the advanced facilities have this pressure differential meters, which will be is showing in the range of 10 to 30 pascals. So these are important things which you have to notice right early in the morning. You have to come and see whether the pressure is right, whether the machines are working fine or not, and relative humidity and temperature. And these are very reasonably priced devices which you can order from online portals. So the instrument is thermohygrometer. It shows temperature and humidity, what percentage humidity is in the lab. Very important, useful instrument. So nowadays things are changing. Now we have got AI coming in. AI has not left IVF also far behind. So we are definitely using AI. And with the new AI workflow, there are sensors installed which send information to cloud database, and with the help of AI, a pattern is recognized, a risk is predicted, and the recommendations are sent to embryologists. So this is a time of AI, and you can't be left behind. And the more information you feed in the AI, there is a continuous learning, early prediction, reduce human error, and it improves your lab consistency. Also, there is a thing known as Internet of Things, in which all the lab instruments, all the macro environment and micro environment, they are integrated with the help of internet. So anything which goes wrong in incubator, or there is something wrong in VOC, HVAC, particle counter, CO2 analyzer, everything is being relayed to a cloud dashboard, and the corrective action is being taken with the help of artificial intelligence. So lab becomes one intelligent ecosystem with the help of IoT. Now this has this has given rise to the term known as smart HVAC. We are using HVACs where you are manually detecting whether there are anything wrong, and we are adjusting the HVAC. Nowadays, you have got HVACs which are smart, which have got sensors, and they automatically adjust their performance. So if there's a fire in the neighborhood, it will quickly detect it, and before you reach, the HVAC has taken the corrective action. Now, this is something. Now the things are shifting from it helps in predictive maintenance, AI integration and smart labs, and they analyze data, and then they modify the fan speed, energy consumption, and prevent VOC breakthrough. So the benefits are there are no unexpected failures, maintenance cost goes down, and there is a reduced lab downtime, and embryonic safety is enhanced. So the future smart lab is something which is not reactive. Like I detect some changes and I react to it in my HVAC system. But now it is predictive. With the help of AI, and digital twin labs have come in which, with the help of AI, you can quickly detect that something is going wrong, and predictive analysis is done. Even you know that my filter is going to be exhausted in the next 2 weeks, and AI will give automatic recommendations. So times are changing, and to give the best and possible chance to our patients and to our embryos, we have to integrate these technologies in our lab in times to come. Because manually, it is not only difficult, we have seen it's next to impossible to, have a person monitoring everything 24/7. So with this, I would say that culture media is only one component of embryo culture. The true culture media is the entire lab environment, and the embryo spends 5 to 6 days in our lab, but those 5 to 6 days determine an entire lifetime. Every breath the embryo takes matters. So you have to feed in most pure and most clean air to the embryo because it cannot detoxify. It has got nothing to detoxify things. With this, I end my presentation. I hope I'm sorry for the little inconvenience because of computer malfunction. So if there are any questions, I'll be happy to answer. Dr. Lakshmi, are you there? So I would just like to remind you that today is the last date for early bird registration, and from tomorrow there'll be a small nominal hike in the fees for clinical embryology 3.0. So this is the right time to register today. And we have got excellent faculty with Dr. Lakshmi, Dr. Fiona coming in, and excellent topics. So please make use of this opportunity. So if there are any questions, I'll be more than happy to answer. I can see some comments in the chat box, but I can't see any questions. Dr. Archana, are you there, ma'am? Good evening.
Yes.
Yes,
Thank you,
hello,
sir,
ma'am.
for a wonderful presentation.
Thank you, ma'am. How are you, ma'am? And how is the lab doing now?
Lab is going nice, and that last the course which I have attended of the embryo transfer and that with Dr. Monica Verma is very good. Day before yesterday, I have discussed so many things about that.
Very nice.
Now the lab is going well.
So after the audit, things have improved, I believe.
Definitely,
Mm.
definitely. And Shivani people has really taken care of the lab. Thank you, sir. Okay.
Thank you, ma'am. Thank you. So I don't see any questions now. So if there are no questions, we can call it a day. And
It was a wonderful presentation, and I have joined that also whenever you have given that in previously a course I have attended in which you have told about the whole environment, about the lab and everything. So
yes, ma'am. So
it is
actually,
always
lab actually decides, how well the embryos will implant. So if we are not careful of the lab environment and the culture conditions, then things may not
it
be.
is really important. Now the lab
Yeah.
is going well.
Yeah. Consistency should be the key actually in IVF.
Okay. Thank you, sir.
Thank you, ma'am. Thank you. So if there are no questions, we'll end the presentation. Thank you so much. Thank you. Dr. Lakshmi, unmute yourself, Dr. Lakshmi. Yeah.
Sir, it was a wonderful presentation, sir. You covered everything. And that's
Yeah.
why I think nobody has any questions on that. Actually, it is a topic which is less spoken, I think, sir. Many of the places there won't be any discussion on this. At least now
Yeah,
it's
tough
some
topic. Yeah, it's a tough topic, but it's very interesting topic. I think this is
definitely
something.
important also.
Yeah, because in lab environment, I think is the key to success and consistent results.
Many of and also the embryologists will know very less things about this, and they will not give so much importance also. The thing is, they know that it is important, but they will not know about how to deal with that when it's
Yeah.
something wrong. Yes, sir.
And believe me, it's not that difficult. Even very small, simple, and inexpensive changes go on to improve the lab environment to a great deal
Yes, sir.
and enhance the results. Yeah. So I think we'll end the meeting now with your permission.
Yes, sir.
Yeah. Thank you. Thank you. Good night. Good night. Take care.